Now in physics, we do believe very strongly in the conservation of energy. Not necessarily in the conservation of kinetic energy, as you have seen last time. You can destroy kinetic energy. But somehow we believe that if you destroy energy, it must come out in some other form, and you cannot create energy out of nothing. And in the case of the completely inelastic collisions that we have seen last time, we lost kinetic energy, which was converted to heat. There was internal friction. When the car wreck plowed into each other, there was internal friction, no external friction, and that took out kinetic energy. And so, in its most general form, you can write down that the kinetic energy before the collision plus some number q equals the kinetic energy after the collision. And if you know q, then you have a second equation, and then you can solve for v1 prime and for v2 prime. If q is larger than 0, then you have gained kinetic energy. That is possible. We did that last time. We had two cars which were connected by a spring, and we burned the wire, and each went off in the opposite direction. There was no kinetic energy before, if you want to call it a collision, but there was kinetic energy afterwards. That was the potential energy of the spring that was converted into kinetic energy. So Q can be larger than 0. We call that a super elastic collision. Could be an explosion. That's a super elastic collision. And then there is the possibility that Q equals 0. Very special case, we will deal with that today, and we call that an elastic collision. I will often call it a completely elastic collision, which is really not necessary. Elastic itself already means Q is 0. And then there is a case of which we have seen several examples last time of inelastic collisions when you lose kinetic energy. So this is an inelastic collision. And so if you know what Q is, then you can solve these equations. Whenever Q is less than 0, whenever you lose kinetic energy, the loss in general goes into heat.